Let's begin 8.1, characteristics of a quadratic function. Okay, so a quadratic function is a function uh, where y equals x squared. It's not too far off of what we've been dealing with already. So it looks like this, f of x equals x squared. If you remember before, I said f of x it's interchangeable with y. It's the function of x. So x is an independent variable, and when you change x, it changes the dependent variable, y, or f of x. This is the function of x. So, like, you put in 1 squared is 1, so the function of 1 is 1. You put in 2 squared is 4, the function of 2 is 4. Put in 3 squared is 9, the function of 3 is 9. Okay, that's the basic idea there. And then this is what the graph of it looks like, generally speaking. This is another term we introduced in an earlier lesson called the parent function. The parent function is just the normal function without any extra bits or bobbles added. It hits right there at the origin. That's the bottommost point of the U, is right at the 0, 0, the origin. And it goes up in two directions, up into infinity, so that its range, its y movement, is all positive numbers. Okay, so what's the word? Characteristics of a function. Let's say that I've got a function that goes right here. It's off to the side, right? It's been moved, and it's 1, 2, 3 points to the right. Okay. Then what am I saying? Is it's got an axis of symmetry. Axis of symmetry, 1m or 2m's? 2m's. Axis of symmetry. Symmetry, if you don't know, is the word meaning things are identical on the left and the right. That's something that is symmetrical, is identical from the left to the right. So the axis of symmetry here is the invisible line that goes right down the middle. That's a terrible, terrible line. That's much better. There we go. The invisible line that goes right down the middle and splits it exactly in half. And because it touched the x-axis at point 3, we know that the axis of symmetry for this graph is at x equals 3. Right? Does that make sense? The axis of symmetry is at x equals 3, and it splits the graph exactly in half. Okay, that's the first aspect of a quadratic function, is its axis of symmetry. The next aspect is whether it has a minimum value or a maximum value. Draw these real quick. You've got a graph that goes to point 1 on the y, and a graph that goes to point -1 on the y. One opens upwards, one opens downwards. Like so. This one points up, this one points down. This one has a minimum, because minimum means the least, right? The least it can be. And, oh, I hit the board. Look at that. Without even looking at the board properly. I looked at it backwards in the camera. So it has a minimum value because that's the lowest it goes. This one has a maximum value because it goes down into infinity But when you go up, it stops right here. That's its maximum. This is the minimum. This is the maximum. So this one, right? It has no maximum because it doesn't stop. It goes up into forever, for infinity. But it does have a minimum. This one has no minimum because it goes down for forever, but it does have a maximum because it stops at one point. So the graph for this one is f of x equals x squared plus 1. This one is f of x equals negative x squared minus 1. See, because it's been moved down a point, so that's the minus 1, and it points downward. That's why it's a negative x squared. So what you would do there is, like if you inputted a 2, it would be 2 squared is 4, and then it would be negative of that, so it's negative 4 minus 1 is negative 5. If you put in a 0, 0 squared, negative 0 is 0, minus 1 gives you this minus 1. See? It shifts the graph down and makes it open up downwards. Okay. The next one is just another term. It's called the vertex. So this is another parabola. The vertex is this point right here. The point that is either the maximum or the minimum, depending on which direction the graph goes. Here it's a minimum. It's also called the vertex. Vertex, if you've done geometry, I don't know if geometry comes before or after this. Anyway, in any given angle, the vertex is where the two lines meet. If you had a mountain, the vertex would be the apex, the top of the mountain. If you had a triangle, there are 3 vertexes or vertices. And so that's what vertex means. It's the point where 2 lines meet. And since this basically forms 2 lines, you got to say, where do these 2 lines meet? Well, they meet at the minimum. Or if the graph opens downward, they meet at the maximum. Vertex is the word. There's your vocabulary. And finally, the x-intercepts. Not all graphs have x-intercepts. Let me show you some that don't. Here are 2 parabolas that don't have x-intercepts because they never touch the x-axis, right? Here's one that only has 1 x-intercept because that's where it touches the x-axis. Is that the tornado siren? It's a clear day. It must just be a test. Okay. So it has 1 x-intercept, and then let me erase. And then give you this one. Here's its vertex, right? We discussed that just a minute ago. And here are the x-intercepts, the places where it touches the x-axis. Let's say that's at 1, 2, 3, and negative 1, negative 2. That's at 0, 3, and 0, negative 2. No, other way around, because it goes x, y. I lied to you for a second. I'm sorry. It goes x, y. So that's negative 2, 0, and 3, 0. There we go. That makes more sense. So that's the vertex, and those are the x-intercepts. So, if we have this graph, or this coordinate plane, and then we have this parabola, then it's got two x-intercepts. Okay, it's got a vertex. It's got a minimum. The minimum is the same as the vertex. It's in the same place. So this dot has two names. It's got the name vertex and it's got the name minimum. It's got two x-intercepts. It's got a vertex. It's got a minimum. It's got a domain, which is the x movement. Eventually, it'll touch all x's. It'll take a long, long time, but it'll get there, and it'll touch all y's. So all x's greater than whatever this point is. Let's call it -3. It's got to no. The domain would be all numbers. That is not sideways enough to be an infinity. And the range is -3, comma. Why is that infinity so hard to draw for me? Okay. And the range is -3 to infinity because it has a minimum, -3. So all of these parabolas are going to have these aspects, except some won't have two x-intercepts. Some will have one x-intercept, some will have 0. It's a good thing to write these down if you're not already. That's what good note-taking is all about, especially when words come up, terminology, it's good to write those things down. All right, that concludes this lesson. We'll meet you in the next one.